Hi, welcome to the solution video of paper 52, winter 2023. If you like this video, please share with your friends, give it a thumbs up and subscribe to Math United. Let's start with question number 1. A competitor in a throwing event has 3 attempts. To throw a ball as far as possible, the random variable x, denotes the number of throws that exceed 30 meters. Probability distribution table has been shown below. The expected value of x has been given as 1.1. Find the value of p, which is here unknown. It's a probability, and r. Alright. So let's use the fact that the sum of all the probabilities is always 1. So I can say that 0.4 plus p plus r plus 0.15 will be equal to 1. So let's keep the variables on the left side, p and r, and bring these two there. So it will become 1 minus, first we'll add them, 0.55. If I add these two, 0.55, they are positive. When they go to the right side, become negative. So p and r become 0.45. That's our equation number 1. Now let's use the second information they have given, that the expected value is 1.1. What is the formula for expected value? Is sigma px. Okay, so whatever is x, let's make it capital X. Okay, whatever is x multiplied by its probability, and then sigma means add them. So let me multiply 0 and 0.4. 0 is the number of throws that exceed 30 meters and 0.4 is the probability, plus 1 times p plus 2 times r plus 3 times 0.15, it is equal to 1.1. That has been given. So this is 0, this is p, then we have 2r plus this will be 0.45 and 1.1. Let's bring 0.45 to the other side and we get this equation. P plus 2r equal to 1.1 minus 0.45. So P plus 2r is equal to 0.65. 1.1 minus this. So this is equation number 2, and we can use elimination method of simultaneous equations to find p and r now. So let me write this p plus r equal to 0.45 here. So p plus r equal to 0.45 we can write under this and subtract the whole equation from the first one. So p minus p, 0, cancel out. 2r minus r is just r. 0.65 minus 0.45 is 0.2. So we got r equal to 0.2, and let's use this equation, p plus 0.2. I substituted 0.2 in place of r to get value of p, 0.45. So p comes out to be 0.45 minus 0.2. So p equal to 0.25. We got p as well as r, which was asked in this equation. Alright, let's do this. Find the numerical value of variance. Okay, so let's do it here. The formula for variance is again sigma, but this time x square multiplied by its probability minus whatever was the expected value, is a square. So expected value was 1.1 given, so no issues here. This will be the one we'll be doing based on the table again, but we'll square the x first. So here we have 0, 0 square. Multiply by its probability, 0.4. Then we have 1 square. Multiply by its probability p, which is 0.25 now. Then we have 2 square multiplied by r, which is 0.2, and finally we have 3 square times 0.15, and let's solve it. This is 0, gone. 1 times 0.25 is 0.25. 4 times 0.2 will be 0.8. Okay, then minus. Okay, then we have this all. 9 times 0.15. Okay, it will be plus 1.35. And minus 1.1 square will be 1.21. And that comes out to be variance. So this plus this will be 1.05, this plus this will be 2.4, 2.4 minus 1.21 will be 1.19. That is the variance. Got it? Okay, let's move on to the question number 2. Okay. Question number 2 says that George has a fair 5-sided spinner. Okay, let's say that is the spinner with label 1, 2, 3, 4, 5. He spins the spinner, and because this is fair, they said fair, right? That means it will be a pentagon, kind of. We can say 1, 2, 3, 4, 5. Okay, all are equal spaces. Okay, they are not equal in this picture, but they are because of this word fair. Okay, on which spinner lands, that is the number. Find the probability that it takes fewer than 7 spins for George to obtain a 5. First of all, probability of 5 is P, which is probability of success. And what is the probability of 5? Which is 1 over 5, because all of them are equally placed, so the probability of 5 is 1/5. Now they're saying that it takes fewer than 7 spins. Fewer than 7 means confirmed success in 6 spins, correct? If we want success of 5 in fewer than 7, that means in first 6 spins 100% you get a success, right? But if we can rewrite this, that there is no failure in all first 6 spins. Yes, we might have gotten a success in first or second or third or fourth or fifth attempt or sixth attempt, right? But it is confirmed that there is no failure. So if the probability of success was 1/5, what is the probability of failure? Q, 1 minus 1/5, which is, let me write here. Okay, 4/5. Okay, so let's interpret this. There is no failure in all 5, 6 spins. So it will be that there is no failure. We write 1 minus, and there is no failure, 4/5 to the power 6. There is no such case. Okay, and that will be 1 minus this. And if I use my calculator, I'll get that answer. By the time I use my calculator, I would like to request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 0.7378. So I can write 0.738. That is the probability that he gets success before the 7th spin. That means it does not failure. There's no failure in first 6 attempts. Okay. George spins the spinner 10 times now. It's fixed 10 times. Find the probability that he obtains 5 more than 4 times but fewer than 8 times. That means, again, the probability of success P is 1/5. Probability of failure is 4/5. But now our successes are fixed. Earlier there was no success. There was just a statement that you get success before 7. Now we have confirmed that there were 10 attempts were made. Okay, so when 10 attempts were made, that the success, let's call success number of success equal to x. So px is equal to, they're saying more than 4 times. So they get success more than 4 times, that is 5 or 6 or 7, but not 8. But not 8, fewer than 8. That means we have to stop here. So we have these 3 conditions which are more than 4 or less than 8. So let's interpret this into binomial probability now. Why? Because we have fixed number of attempts. When we have fixed number of attempts and we have success or failure, only 2 possibilities, and all attempts are independent, then we can use binomial probability. So in this case, total attempts were 10. So we'll interpret this as 10C5 because there are 5 successes. What is the probability of success? 1/5. Rest of the 5 will be failures. Plus 10C6, 6 successes, and 4 failures. 6 plus 4, 10. The sum of 6 and 4 must be equal to this number 10. And this number must match. 10C7. Now you guessed it right. 1/5 to the power 7. 4/5 to the power 3. Just put them separately in a calculator and you'll get it. Let me try it myself. So for this first one, 10C5 and this, I get 0.02642. 0.0264 plus 0.005. Okay, okay, let's make it 1. And then we have this one, 0.000786. So if I add these total, I get 0.0323. This is the probability that he gets success more than 4 times and less than 8 times. Okay, shall we go to the next one? Yes, we do. A factory produces a certain types of electrical component. It is known that 15% of the components produced are faulty. Okay. So a random sample of 200 components is chosen. Use the approximation. They're saying approximation, and we know only one approximation, that is normal approximation. Okay. To find the probability that more than 40 of these components are faulty. Before we approximate, we'll have to check whether NP is greater than 5 or not, and NQ is greater than 5 or not. So what is N and what is P? N is total number of selections, which is 200 in this case. P is the probability of success, which is 15%. So in decimals, it is 0.15. And Q is the probability of failure, which is 1 minus 0.15, which is 0.85. Okay, so let's see. N 200 times probability of success, which is 30. Yes, 30 is greater than 5. Done. It's good. Obviously, if I multiply by 0.15 and if I multiply by 0.85, it will definitely be even more than 30. Right? It will be 70, 170. 170. So this is also more than 5. Test is complete. We can use approximation. For approximation, we need mean. Mean is NP. So mean is 30. We already got NP as 30. Now we need standard deviation, which is square root of NPQ. So in that case, it will be 200 multiplied by P multiplied by Q. And let me use my calculator to find this. By the time I do this, I would request you to like this video, share this with your friends, and subscribe to Math United. That will definitely going to motivate me to make many more videos in coming days. So what I'm getting here is 5.049. So let me write 5.05 is the standard deviation. Now we have to approximate for more than 40. So first let me try to visualize this. If this is normal approximation, mean is 30. We want more than 40 to be faulty, success. So this is success and this line is 40. They said more than 40, that means 40 is not part of it. So if I want to make more than this, more than 40, that means 40 should not be part of it. So I will approximate x, the variable x equal to 40.5, so that 40.5 and above will be included, 40 will not be included. So this is what I'm going to use, and for that I need to find z value first. So z, let me write here z value, which is the variable minus mean divided by standard deviation. So variable is 40.5 minus mean is 30 divided by the standard deviation, which is 5.05, 2.0792, which is 2.0792. Now if I try to find it out looking at the table, it will give me this area, because it's always less than what number we get from the table in the formula sheet provided to us. But I want this more than. So whatever probability I get for z is less than 2.0792, that probability will be this one. I don't want this, so I will make it 1 minus. Okay, so let me use my table 2.0792. 2.0 is here, 2.07 will be 0.9808, this one, and then we want 9 also after this. 2.079. 9 is the last one, which is how much? 2.0 here, 4. Yeah, this 4. So 9808 plus 4 will be, make it 0.9812. 0.9812. So 0.9812. 1 minus 0.9812. And if I subtract it, how much it comes out? 0.0188, right? And 3 single figures are already here. Yes, this is the probability that we'll get more than 40 faulty components in a set of 200. Very, very less probability. Alrighty, question number 4 comes up here. The heights in centimeter of 11 players in each of 2 teams, aces and jets, are shown in the following table. So these are the heights: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Draw a back-to-back stem and leaf diagram to represent this information with aces on the left. So let me put a line here and put a line here. Okay, and okay, let's write what is the smallest height here. 169, 166, 164 is the smallest in the first one, which is for aces. They said aces on the left hand side, so aces will be here, and jets will be on the right side, obviously. So 160, right? So 16 I'm writing here. What is smallest in this one? 166 here. Okay, 160, so 16. So let's start writing more. Then we have 17 also. Then 18, 180 is also there. Is there 190? Yes, there is 190 also. So 190. So before I proceed, I will write key here. Key is that 1, 7, 4 and 5. represents 174 for aces and 175 for jets. This is the key. So we'll write one by one. I'll keep some spaces because some they are in random order. So 180 is the first one for aces. So zeros. The smallest one comes to the right in left side. Okay, don't start 0 from here. That will be wrong. So 0 here. Then 174. 174 I will write here. Maybe something below that. 169. 182. 181 also. So 1 is 66. 173. 182 again. 168. 171 and 164. So now I can put commas in between them. So this is for aces. 1 2 3 4 5 6 7 8 9 10 11. Always count so that you ensure that you didn't miss anything. 175 first, then 174, 188, 168, 66, 74, one more, 181, again 181, 170, 188 and 190. So you can close the gaps accordingly. 1 2 3 4 5 6 7 8 9 10 11. Done. I have drawn the stem and leaf diagram back to back for these two, aces and jets. Find the median and the IQR, interquartile range, of the heights of the players in the aces only aces, this one, right? So for they are how many? 11. So for median, so 11 add 1 to 11 divided by 2, which is 6th place. 6th person in ascending order is the median. Let's see what is the 6th if I start from the smallest one. 1 2 3 4 5 and 6, which is 173 centimeters. Next I need IQR. For IQR I need upper quartile, which is Q4, and lower quartile, which is Q1. Pardon me, Q3 and Q1. So Q3 is the median of the upper half excluding 173, excluding median. How many we have now? 1 2 3 4 5. So it will be 5 plus 1 divided by 2 again. So median of upper half, except for this, third position. Any number that is on third position. So third position is this 3 is gone. So 4 is first, second, third. 181. That gives us 181 centimeters. Q1 is again the median of the lower half excluding 173, and that will be again third. So 1 2 3 in ascending order, 168 centimeter is Q1. However, they asked us to find out IQR, interquartile range. So interquartile range is Q3 minus Q1, which is 181 minus 168, that is 13 centimeter. This is IQR. Let's go to the C part. What does C part say? C part says this. Give one comment comparing the spread of the heights of aces with spread of the heights of jets. So just 1 mark question. So we can see that it is these data points are very close to each other. The smallest here is 164, the smallest here is 166. However, the higher one is 190 here. It looks more spread out. We have just 2 here, 4 of them here. So we can say that since they are asking us to compare the two heights, spread of the heights, so we can say that the heights of jets are more spread out than aces. Okay, otherwise you can also find IQR for them and see which one is giving you a smaller bigger number. Accordingly you can write. Okay, question number 5. The heights of a club are normally distributed again. Okay, so we had normal approximation earlier. Now we have normal distribution. Mean is 166. So mean is 166. Standard deviation 10 centimeters again. Okay. Find the probability that a randomly chosen member of the club has height less than 170 centimeters and less. Visualize this again. That helps us a lot. So this is normal distribution. Mean is 166. We want less than 170. So suppose this is 170. We want less than this, and which is very good for us. Why? Because our table gives us less than only. So doesn't matter, we will just find Z score for this, which is X, the data minus mean over standard deviation. Data is 170 minus mean is 166 divided by 10. So 4 divided by 10, 0.4. We'll go to our table straight away and see what do we get there. Okay, 0.4, 6554, 0.6554. So probability that X is less than 170 is 0.6554, but I will write 0.655 only. Why? Because we want 3 significant figures. That's why. Okay, let's see what is the second part saying. Given that 40% of the members have heights greater than h centimeter. So let me redraw this for this particular part. Okay. So 166 again. And greater than h centimeter is 40%. We know this is 50%. More than mean is 50%. That means that height h is somewhere here, and this is 40%, 0.4 as the probability. Find the value of h correct to 2 decimal places. Okay, so first I will find h based on this. What is the score less than this? What is the probability less than this? So probability that x is less than h is 1 minus 0.4, which is 0.6. That's the probability of this less than part, because our table again belongs to only less than, not more than. So I'll go to table again and see what do I get for 0.6. What is the Z score? Okay, so here it is, 0.6 is the probability. This table is probability here. So we'll go to the probability here, 0.6, where it is 0.591, 0.5987. This is the one. 0.5987 gives us Z score of 0.2 and 5. 0.25, and I need 13 more. 13 more to make it 0.6. 13 will be between 3 and 4. Closer to what? Closer to 3. So I'll say 0.253 is 0.253 is our Z score. So 0.253. Okay. Formula for Z score is again same, x minus mu over standard deviation. So Z, in this case x is not x, it is h. Okay. So Z is what? 0.253 equal to h minus 166 over 10. Let's cross multiply here. So it becomes 2.53 equal to h minus 166. I'll bring 166 there. So 253 plus 166 equal to h. And we got x equal to 168.53, which we have to round out to three single figures, 169. Okay, they said two decimal places, so not three single figures. This is the right answer. We can stop it here. Okay, there's one more part which says the random variable x is normally distributed with the mean, so it has nothing to do with the previous one. So normally distributed with mean equal to mu, standard deviation equal to this. Given that this equal, find the probability that the randomly chosen value of x is positive. So let's try to visualize this. If this is normal distribution, this is mean, and suppose x is somewhere, suppose here. It's possible that mean is positive or negative, right? So this is 0, or it can be here also. It can be 0 here. Mean is negative, it's possible, right? But they're saying that it is greater than 0. Positive means what? It is greater than 0. Wherever it is, whatever z score is for 0, this is the z score. We'll get z score and probability in this area again, right? For 0. We want more than that. So again, what will I do? I will find the z score for 0 first. Z score for, let me rather write it properly, mathematical way. X is greater than 0. Z score for that will be 0 minus mean. Mean is mu over sigma, right? And sigma, they have said it is 2 over 3 mu, which is minus mu over 2 over 3. I'm not writing over 3, I will write 3 here. And mu, right? 2 over 3, whenever there's a denominator, we can write it as numerator. So mu and mu cancel. It comes out to be negative 1.5. Which means that my assumption that it is here is wrong, because z score comes out to be a negative number. It is less than the mean. That means 0 actually is here, and we have to find this probability. With this z score, I will get this probability, this smaller one. So probability that z is greater than 1.5, negative 1.5 rather, will be 1 minus probability that z is less than negative 1.5. So let me go back to our table and see what do I get as probability for negative 1.5. We don't have any negative here, so we'll take for positive 1.5, 0.9332. Okay, so this is negative 1.5. Z equal to negative 1.5. This is what I wanted, but in my table there was no negative, so I will take the positive one. This positive 1.5, and we got 0.933, right? 0.9332 is the probability when z is less than positive 1.5. That means from here, this whole area is 0.9332. But I wanted this and more. Don't you think it is a reflection of whatever I got of this one? Yes, same area is this, positive 1.5 and less is same as negative 1.5 and more. So what I got here, I will not use it, or rather I can use it. 1 minus 0.9332. That's what I'm trying to say here. So it will get 1 minus 1 plus 0.9332. So I got the same thing again, because it's a reflection, because 1 minus 1 cancel out. So answer I get is 0.933 only, not 2, because 3 significant figures. Question number 6. Okay. Freddy has 2 bags of marbles. Bag X contains 7 red and 3 blue. So let's say this is bag X. It has 7 red and 3 blue. Okay, Y has 4 red and 1 blue. Okay, 2 colors only. Freddy chooses one of the bags at random. Okay, so there are 2 bags. They have equal possibility of being chosen. So probability of bag X is half. Probability of bag Y is also half. 1 out of 2. A marble is removed at random from that bag and is not replaced. Okay. A new red marble is now added to each bag. Alright. The second situation is different. So first situation is different. Second situation is different. Okay. I'll just keep it in mind for the time being. Okay. Then a second marble is removed at random from the same bag that the first marble had been removed from. Very, very complicated. Good. Draw a tree diagram for representing this information, showing the probability on each. Okay. So the first event is that we choose a bag. Bag is either X or Y. Probability of bag X is half. Probability of bag Y is also half. Then we remove a marble which can be red or blue in this case. Red or blue in this case also. In bag X, what is the probability that I get a red ball? There are total 10. So 7 out of 10 is probability of red. Remaining 3 out of 10 blue. Similarly, for red here is 4 out of 5. And this is 1 out of 5. But something interesting happened after this. Something in this case, in this branch, bag X was chosen and red ball came out. Right? Red marble came out. And then that red marble was again put back because only red. Here then removed. What is it? A new red marble was added. So by chance here red was removed, again red was put back. So it is the same situation again. So probability of red and blue remains same in this case. However, in this case, if blue marble came out of this, so one blue marble has gone down. Yes, which is just 2 blue now, but one red was added, so it becomes 8 out of 10 for red. And this is just 2 out of 10 for blue. I hope you understand, because one blue ball has been removed, but red is added. Let's do it here. Same thing. Red and blue, because it was red already and red was replenished, so it will remain 4 out of 5 here and 1 out of 5 here. Here blue was removed. There was only one blue and that is removed. That means we have 0 probability for blue now, but here we have 100% chance that we'll get a red ball. This is the tree diagram for the given situation. Okay. Find the probability that both the marbles removed from the bag are of same color. Both. So either it is red or blue. Alright. So we will look at the branch where we are getting red. We are getting first this half bag is chosen. Then we get a red which is 7 out of 10. Then we get a red again, which is again 7 out of 10, so I can square it. Or same bag was chosen, but a blue came out, 3 out of 10, and 2 out of 10. Blue. Yeah, blue and blue. Or this branch. So this plus this will happen half. This bag was chosen. Then we have red 4/5, then 4/5 again. Okay, I can square it. plus half blue, which is 1/5, and then 0. That means this one is gone. Okay, there can't be two blue balls in this case, only these three. So what do we get here? 49 over 200. 49 over 200 plus 6 over 200. Let me not cancel out because their denominator will be same. 6 over 200 plus 16 over, this is 25 times 200, 50. 16 over 50. So let me multiply this by 4 so that I get 200 here as well. So 49 plus 6 is 55 plus 64, 119. 55 plus 64, yes, 119 over 200. This is the probability that both of the marbles are of same color. Okay, question number 7. Find the different arrangements of the 9 letters in Andromeda, in which no consonant is next to one another. How many consonants are there? N is a consonant, D is a consonant, R, M, and D. They are not. No consonant is next to each other, so they are not. 1, 2, 3, 4, 5. 5 of them are not next to each other. That means we will just arrange the others. A, O, E, A. A, O, E, A. Right? E, A. Okay. So 4 factorial ways they can be arranged, correct? These A, O. But A and A are exactly same. That means we have to divide by 2 factorial. Now, there are how many places? 1, 2, 3, 4, and 5. I will put 1, 2, 3, 4, 5. These 5 places will be taken by these 5, right? So they will be taking place in 5 factorial ways, right? But D is repeating here as well. R is not repeating, M is not repeating, and N is not repeating. D is repeating, so 2 factorial. We don't have to select any position because these 5 are fixed for those 5. So answer for this 4 factorial will be how much? 24 over 2 times 120 over 2. 12, 60, 720 ways. B part. Find the number of different arrangements of 9 letters of the word Andromeda, same, in which there is an A at each end. 9 letters. They're saying 1, 2, 3, 4, 5, 6, 7, 8, 9. This is taken by this A, taken by A, and even if they change the places, that's not a different arrangement, so don't worry about A's anymore. So A's are gone. Now we have how many left? 7. So A at each end, and D's are not together. How many D's are there? D, 2. So let's say that those D's are together. Okay, put them together. How many ways can they be together? So this is one place, and now they are together, so this becomes one place. This. How many are these? 1, 2, 3, 4, 5, 6 ways they can be together. Don't worry about A's because they are fixed. But we don't want this, right? We don't want them to be together. So how many total ways are these, including these D's, how can they be arranged this different ways, or arranged in different ways? So that will be, there are 7, right? 1, 2, 3, 4, 5, 6, 7. 7 factorial, and D is being repeated. That's why we'll divide by this. This is the total number of arrangement. This is when D's are together. So we subtract those cases when they are together, so they will be separated. So this becomes what? 5040 over 2 minus 720. So 2520 minus 720, which is 1800 ways. Next, 4 letters are selected at random, selected not arranged, from 9 letters of the words. Find the probability that this selection contains at least one D and exactly one A. Okay, so the case here is that at least one D and exactly one A. So at least one A, sorry, exactly one A and at least one D. So one D is here. Exactly one A and two Ds. That is also part of at least one D, but we can't have three Ds because there are just two Ds. So these are the only cases we are selecting 4 letters. So that means we need 2 more and only one here. So first we have to select A, which one will be part of it. Then we have to select D, which will be part of it out of 2 Ds. And now we have total 9 letters. Out of that 4 have been taken care of, 5 are remaining. So out of those 5 we have to select 2. Okay, and this is how much? 2C1 will be 2 times 2 and 5C2 will be 10. So 2 times 2 is 4, 4 times 10 is 40. Here 1A is to be selected, then okay, both of them are already there. 2C2 is 1, so both the D's are here, so no need to take care of that, but we have to select 1 out of remaining 5. So it will be 2 times 5, 10. Right? So total selections are 40 plus 10, 50. Right? However, they are asking us the probability, not the selections. So 50, let's write probability equal to 50 out of total selections. There are 9 letters. We are selecting 4 out of them, 9C4. So which is 50, 9C4. Let me do this. By the time I do this, please let me use my calculator for this. So by the time I do this, I would request you to like this video, share with your friends and subscribe to Math United. I'm going to make many more videos in winter 2023 paper set very soon in coming days. 126 I got here, so this will be 25 and 63. That is the probability. 25 out of 63 is the probability. That concludes our solution video. I request you again to like this video, share with your friends and subscribe to Math United. Thank you very much for your attention.